I'm going to work a couple of examples from Chapter 2. If you need anything else worked, just let me know, and I'll be glad to make a video or work the problems with you live on Blackboard Collaborate. Now this U that you're seeing, that symbol there, represents union. And the union means A1, A2, that just means everything. Intersection means what's in both. Tell me what's common to both. So, let's see, I'll move our screen around here. And let's just look. I'm going to kind of fill in this circle here. We'll pretend like that little blue's not there. And I would like to do, I think I'll do this one first because it would be the easiest. So we're going to look at this one first. A1 union with A2, and just do them two at a time for me. A1 union with A2. So that would be everything that's in A1, chunk, 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 and A2. There it is. Now it says also put in your set everything that's in A3. Oh, that would just be everything shaded. That one's the easy one. I like that one. Let's do the intersection one next. This one would be the easiest next. It says, I'm going to do this part first. A1 and A2, what do they have in common? That would be this section here. Intersect that with A3. So that would be in total. Let me get a different color because now what I need to do is what does that have in common with A3? So the answer would be the red section here. Oh, that's the answer to this particular circle that I happen to be drawing on. Alright, now let's go to a doozy. Let's figure out what's going on with this guy here. I need A1 and what he has in common with what's not in A2. So A1 and what's not in common with A2. So what's not in A2, but what is in A1 would be this section right here. Get me a different color pen to do the next part. Now I need to take what's in red and intersect that with what's not in A3. Well, this stuff right here is in A3, but I don't want that part. So what I want is this section right here. So my answer would be, and I think I will mark it in, like, let's say the real answer is in purple. That would be this right here, since I kind of marked on that one part of A3. So there's the answer. Oh, that's this one right here, isn't it? So this would be the answer to this first one. Next we'll look at this guy. Now this happens to be part of this one right here. So I'm going to use that result that I just got, which is here, and I'm going to get me another color pen. I'm going to use that and say, oh, this one right here is this. So I've got this one. Now I need to figure out what this little mess is right here, and I'm going to union that, so that just means put it all in the same bucket. So what's not in A1 but is in A2 and not in A3, so that would be this section right here, just following the pattern from the first one. And then I bet they make me do that with A3. Yes, they do. So that would be this section right here. And that's the answer to what this fourth line looks like. Alright, doing this one right here, and I'll do this one in cherry red. This tells me to do what's in parentheses first, so I need to figure out what's in common between A2 and A3. So that would be, in red here, would be this section. and then union that, so that means all of this together, with union that with what's in A1. So all of this is in A1. So I want all of A1 plus that little bitty section sticking out there. So that would be the answer to the last one. Choose number 4 out of chapter 2, and how I arrived at this answer is I just started writing down what I knew. Suppose that 40% of all adults consume coffee, so I say probability of coffee, I'll call it C, is 0.4. Probability that we consume soda, probability of soda is 0.45. Probability, at least one, so that would be coffee or soda, would be 0.5. What's the probability that we consume both? So that would be probability. Now remember that on some of these people were counted twice, so you have to make sure we're going to have to take out the doubles, because they are going to be in this list. There's also going to be in the coffee list, there's also going to be people that drink soda and vice versa. So we're going to do the probability of the coffee plus the probability of the soda, and then we're going to subtract out all of those doubles where they were doing coffee or soda. So what I do for that is I'm going to say that's going to be 0.4 plus 0.45 minus the 0.5, and that's how I arrived at my 0.35. And the B question was pretty easy because it's just the opposite of if you're not drinking coffee or soda, that it's just the opposite. It means you're not drinking either of those things. Now I included a cool little video about how to find your permutation and combination button on your calculator, so I'm going to assume that you know how to do that. And now what you're needing to know is how to find those, how to figure out whether it's a permutation or a combination and get those different probabilities. So we have this wine list here, and your numbers are probably different than mine because all of these numbers, the 10, the 9, the 12, are randomized numbers, but solving it is the same. If you want to serve 3 bottles of Zinfandel, and serving order is important, so if order is important, I know I have a permutation. How many ways are there to do this? So I know that I have a permutation. So in your calculator, you're going to want to choose Zinfandel. Where are you? 10 permutation, and for this you'll hit math, scroll to probability, and then scroll down to NPR. So it's 10 permutation, choose 3, and then that was how I got the 720. For the B question, 6 bottles of wine are to be randomly selected from 31. How many ways can we do this? So on this one, ordering isn't important. I just want to know how many lists there are. So it's a 31 combination because order is not important. Choose 6 and punch those buttons on your calculator, and that was the answer that I got. 6 bottles are randomly selected. How many ways can I get 2 bottles from each variety? This is a multiplication principle because for each of my different lists, I can have another, for each of my Zinfandel lists, I can have one of the Merlot choice or Merlot lists for each of, and vice, So what I'm going to do now is I'm going to say, okay, there are 10 bottles of Zinfandel, combination, because order doesn't matter on this, choose 2. That's how many we're choosing. And then times 9 bottles of Merlot, 10, combination, choose 2, times 12 Cabernets, combination, choose 2, and then I just pushed enter and got my answer. Question D. 6 bottles are randomly selected, 2 bottles of each variety. So this is basically, it's just answer to C divided by the answer to B. So it's C divided by B, because B is the total number of different lists we have, and C was how many are ways for us to choose those 6 bottles and 2 of each. So take your answer to C and divide it by B. For question E, I've got to do a little calculation on that. This is an OR. 6 bottles are randomly selected. What's the probability that all of them are the same variety? That means that I want all 6 bottles to be Zinfandel, I want all 6 bottles to be Merlot, or I want all 6 bottles to be Cabernet. So what this is going to be, and since it's an OR, I'm going to add. On my ands, I multiply. So I'm going to say that it is a 10 combination 6 for, there's the total number of different ways, total number of lists where I have 6 bottles to choose from. 6 bottles where 10 was my major number. So it was 10 choose 6. Then it was 9 combination choose 6. And then it is 12 combination, oops, that's not a C, combination choose 6, all divided by the total number of different lists, which is the answer to B, or 31 choose 6. And that's how I arrived at that answer. Now that concludes my examples for Chapter 2. If you need something else worked, just let me know.